Today's talk is what can possibly go wrong? Lessons in building resilient systems. The motivation of this talk is that we all know the cost of maintenance and software is huge. And we all know that the outage sucks for everyone, especially the on-calls to wake up in the middle of the night, solving steps, thinking, what am I doing with my life? You might be waking up your neighbors, yourself, your spouse, your dogs. It's not a pretty scene. And the question I keep asking myself is how can we prevent outage from happening in the first place? And this talk will talk about a few real life scenarios, some lessons we'll learn, and we put it all together on how do we build resilient software. Let's first start with real stuff happen and their lessons. The first one is flood traffic. You get alert about CPU near 100% in your host, followed by availability drop, high client-side error rate. The background can be there is unpredictable site-wide event with just simply more traffic. We're sending traffic to you, more traffic, and then you're seeing an auto-scaling panel if you're using cloud provider that the hosts keep getting replaced because they fail health check. And you're like, what's going on? I'm just getting more hosts to it, but they keep failing. The host stays down. And then you see that the host is down because it failed the health check. So when the host has 100% CPU, it cannot respond ping back to the auto-scaling service, and auto-scaling console will think your host is down. So you really can't spin up any host back on. What do you do then? You might then realize that you just have dropped traffic for it for the host to spin back on. When host doesn't get traffic, it doesn't go down or to 100% CPU. So you can draw traffic, and then you can just a mass connection to the host that instead of getting all these connections to your host that you cannot handle, you can set a mass connection to handle only the connections you're possible to have for your host. So the lesson here is that for the long term, you should do load testing on mass connection a host can possibly handle. So you don't run into issues of host getting too much traffic and lead to 100% CPU in your host, and you cannot spin up any hosts because it keep going down because of the traffic. Right? It's a really bad loop of situation here. The next one is a retry storm. So you can get alert something like client availability below X%. And then if you take a little closer, you see the traffic goes up very high. And the crux of the problem here is that a lot of services like to see when they see an error, then they retry. So if each microservices retries, the number of calls to the database will then multiply. Let's take this example on the right here. So you have, let's say, a site calls the service 1. Service 1 calls service 2. And service 2 calls the database, and database says it's not available. And then service 2 retries 2 times and still not available. So you go back to service 1 saying it's not available. Service 1 says, let me retry 2 times. So you go back to service 2 for each of those service requests. It retries 2 times again. So the total retry now becomes 6 times. And just imagine if you have more services in between and more retries for those services, this can easily multiply and multiply. And then the service at the bottom layer will get overwhelmed, cannot handle any possible traffic. So the mitigation here happened on the big shopping events. It was to drop majority of the traffic, significant drop in traffic to mitigate this, and later added retry configuration changes and more hosts. So the lesson here is to really standardize retry logic, such as exponential retry, respect to too many requests, HTTP code, and also add circuit breaker for dependency. So circuit breakers are ways to say, hey, if a dependency getting too many errors, I just stop calling that dependency because I don't want to made matter even worse for that dependency and being good citizens of not causing a retry storm to services downstream. This one is about plan B went poorly. So alert you might get is dependency availability below X%. So sometimes there are more than one dependencies to satisfy what we need. In the case of circuit breakers, if there is a troubled dependency, we send traffic to another dependency. Now, dependency B also serves on traffic in many cases. So dependency B will immediately go down because it's unable to handle this newly sent traffic and cause problem to services using dependency B. So it may matter worse, not only your service not working, you also may other services failing. The mitigation here is to really focus on fixing dependency A and how to fix what's the issue in there. And a lesson here for the long term is to not introduce a backup dependency unless it's really been prepared well enough, such as acting as a lever for high velocity events. And in day-to-day operation, focus on the plan A that will keep your service up and running. The next one is a very common one, is a bad commit. Alert you might be getting is server availability drop 100%. A bad commit that can go out of production is not really the fault of the commit owner, but rather lack of proper process to prevent it from happening in the first place. You think about lines of defenses, right? So you have code review, you have testing that covers all aspects of the flow, such as unit testing, end-to-end testing, menu testing, QA testing, right? And the list goes on. The testing did not catch any of this. And there are the gatings that people typically add to make sure you can flip it back or flip it on and monitor the feature releases. And there are things like change management, risk assessments, and there are pipelines to get all these changes, put it all together. So let me ask you this. If you have all of this and still do not catch a bad commit, is it really the fault of the person writing the commit? Especially that hasn't happened before? No, right? So every time there's a bad commit, exposes something that's missing. Did this commit somehow bypass the code review? That did not catch this. This can happen. Did it not have a proper testing, or did not follow the guardrail of what's necessary to push these changes out? And somehow we missed all of this. So every bad commit actually carries some positive lesson for you to reflect what was missing in the release process. How can we catch this and prevent it from happening in the future? So in many ways, bad commits is actually a good way to improve your resiliency in your services. Now, the next one is lack of sufficient ownerships. This one sometimes can be comical. You might receive an escalation of people asking you, hey, user reported they are able to use this feature, and you're thinking, what is this feature? I never heard about it. And then after some back and forth, you're actually the team owning this change and feature, and you have to fix it and also be accountable for the self impact. So sometimes this can happen when there is a team changes. Some code don't have sufficient ownership. This can get to a very bad situations. So you want to avoid that, right? You want to really make sure there's a process of transferring co-ownership. You want to make sure there are sufficient annotations of co-ownership, whether that's in code, whether that's tooling, whether that's a wiki, can all help you to avoid this from happening. script is also very notorious. Some of the very bad stuff are because of people writing scripts and not testing it sufficiently. All right, you might get an alert saying system is down at 0% availability. So you're wondering what's going on. And it turned out to be a script reference in a ROM book that was not tested thoroughly. And the lesson here is to really treat the production impacting scripts or changes the same rigor as production commits, such as sufficient testing, QAs, and proper code reviews. Because remember, production changes are all very risky. And if you don't test your script properly, something bad can happen, especially if it's in the wrong book that people are very likely to execute that script. So make sure you have the scripts tested and any production impacting changes tested properly. Okay, now let's talk about the next topic, which is prevention. Let's put everything together. The first thing is to have a defensive coding practices. A lot of those can actually be prevented if you have a lot of defensive coding practices. But the first one is to gate your changes. In many companies, people typically gate their changes inside some gating, so you can use some server-side knobs to increase allocation over time. This is a great way to quickly roll back and also gradually roll out, so you don't impact as many users. The impact radius will be relatively small. And remember to log any exceptions, corner cases, and also remember to have critical information in your login. If you don't have critical information, sometimes people have to actually make that code changes right away and with deployment to finish. So you don't want that to happen. And do not overly rely on backup options. Like the example I mentioned earlier, it's better to fail fast and focus on plan A. I've seen this many times, like some of the steps are just because it doesn't have proper error handling. This can be like no pointer exceptions in Java. That happens a lot. So ensure you have no-safe coding practices. If you're using a more no-safe languages like Kotlin, you wouldn't have this problem. A lot of modern code programming languages have this nowadays. Remember, set a timeout. So if you're a service calling a dependency and you don't have a timeout and a dependency doesn't have a timeout either, then you got a situation where it hangs, right? So you want to avoid that from happening. And last thing I want to remind is having a good retry practice. Use exponential retry, and then use it very sparingly to avoid a retry storm. The next section we'll talk about is detections. So this has three parts. So first part is alerts. So for alerts, have an operational goal is very important in setting alerts. So why you're setting alerts is to make sure it's availability wise, you want to meet a 99.99% availability or higher or lower, or is it about latency your service is committed to? What's the service level agreement, SLA you have? And based on these operational goals, you can set a reasonable thresholds. And you want to really find the balance between noisy alerts and the miss alerts. If you have a very strict threshold, you will then have very noisy alerts. If you have a very relaxed one, you will have miss alerts. And you can also use the historical data to inform the alert threshold. What was it before? What do we generally meet? What's a reasonable threshold so we don't get too many alerts or miss alerts? Alerts should have a runbook to cover common steps on what to do and lessons from past scenarios. When you're getting alerts, on calls should not be thinking what to do. You should have a concrete runbook with the links, the steps, what to do. You should not be thinking too much. 3 a.m. stuff shouldn't be needing any thinking. Neither are you capable of doing something like that. And dashboard offers a different benefits and it complements alerts a lot, in my opinion. It informs people about general trends. This can be a seasonal patterns. It can help to debug and find correlations of what's happening. Also, in your dashboard, you should have a clear name, time period, and useful reference as a marker. This can be alert set criteria, week-over-week changes. And as part of your operational goal, you should also know your system limitations. If you don't know your system limitation, you're waiting a step to happen. So you want to know what's the maximum you can support. If you're online shopping, you want to know how many orders you can support. If you're running a social media company, you want to know how many users can you concurrently support. And you can know this limitation by doing load testing and prepare yourself for dependency failures or other type of failures by doing chaos testing. So mitigation, when you get alerts, mitigation is like saving life in an emergency room. Time is the essence here. You're running against time. So follow the wrong book. Do not have your random thoughts. Do a brainstorming what's happening. Follow the wrong book. Look at your alerts and dashboard. A few questions you can think about. Is it happening at a specific time? Does it line up with a specific commit versions or gating changes? Is there any exception logs or metric to pinpoint specific files? Are there related issues identified by other teams at the same time? Is it company-wide events? Do you need escalation? Right. And there are also times where you need to prepare for high velocity events. So what are the high velocity events? The high velocity events are dangerous times. You can think about it as, of something you want to prepare for. So this can be an anticipated large increase in traffic. Let's say it's Prime Day, or if it is a feature release of a major feature release, you have a lot of traffic going to your service. In those cases, you will have a risk mitigation plan based on factors such as traffic estimations, the risk. Sometimes it can be beyond just operational. It can be about integrity. It can be about media risk, PR risk. In any cases, you need to set up dashboards and alerts specifically and pay very close attention to critical metrics to monitors and the deltas that this events will bring. You should also have levers for the worst case scenarios. So levers can be, hey, if traffic is 2 times my expectation, what would I do in that case? How am I able to accommodate all that traffic? And this is also a great time to audit your services. So rerun your load test, chaos testing, reassess your levers, think about what things can go wrong, do a check on your service health. Now, when SEF is finished, SEF review, or sometimes in some companies it can be called other names, but the essence is that you review the SEF as a person who went for on call. The SEF review is intended to be a learning experience. It's supposed to be blameless. After the SEF, you want to write a report that includes the timeline of the events. When did it happen? When did we detect it? When did we start root causing it and mitigate this and all these timelines so we can match and find out how we can improve on these timelines, such as quicker time to detect and quicker time to root cause and mitigate the SEF. For the root cause, one useful exercise is think in terms of 5 whys. So for example, your service is down. Why is your service down? Because there's a memory leak in your host. Why is there a memory leak? Because there's a bad commit that introduced a memory leak in productions. And why did this memory leak end up in production? Because we did not have proper load testing to catch memory leak issues. Why do we not have the load tests? And then that comes your action item to add the load tests and the proper guidelines and action item prevent it from happening in the future. In general, you want to focus on the next steps and action items, making sure those action items are tracked, making sure there's a timeline for when those action items will be finished. Because if there's no action items, all this learning is for nothing, right? You need to find ways to prevent it from happening. Very rare cases, it's that this is act of God. There is no possible action items you can take. And at the end of the day, SEF review is really a place to foster this continuous improvements to make sure that people are aware we can build a resilient system. We're able to make it better, make our own calls life better. Yeah, that's end of the talk. I want to thank you for attending this talk. Hopefully there's some takeaways you get out of this talk, and hopefully you have fewer steps next time you're going on call, following some of the lessons we discussed in this sessions. Yeah, thank you.